chemical formula is C4H8NO1. Then verify with the molar mass. If this is also the molecular formula, we calculate the molar mass of C4H8NO and get the total is 72 grams per mole. Based on the IR data, the weight range of 2941 until 2857 show the CH stress which is specific to alkyl group. The carbonyl group which is C double bond O with a clear strong peak at 1715 is most likely a ketone, and CH2 bending is shown by 1460, which further support the process of the alkyl change. We already suspect that our molecule is a simple ketone with the alkyl group based on the IR spectrum. Then analyze with the carbon-30 signal, which is 212 ppm. This carbon is obviously a ketone, which is C double bond O, because to the significant dishes and it is quite downfield. 39 ppm is slightly downfield shift CH2 carbon close to the C double bond O, and 70 ppm the methyl group, and lastly the 9 ppm the CH3 that is somewhat nearly the carbonyl group.
Today, we explore the interpretation of proton and NMR spectra through the lens of our recent assignment. The data provided include three key signals: a quartet at 2.48 ppm in the bracket 2H, a singlet at 2.12 ppm in the bracket 3H, and a triplet at 1.07 ppm in the bracket 3H. This signal reveal the structure, proton environment. The quartet and triplet indicate a CH2 CH3 fragment, where the CH2 in the bracket 2.48 ppm is split by the neighboring CH3 into a quartet, and the CH3 in the bracket 1.07 ppm is split by the CH2 into a triplet. The singlet at 2.12 ppm suggests an isolated CH3 group, likely adjacent to a carbonyl group with no coupled proton. Combine this insight, we deduct the structure CH3, C double bond O, CH2, CH3, butane 2,1, which align with the molecule formula CH4H8O, mHz72. The chemical shift and splitting pattern consistently support this assignment. The downfield singlet in the brackets 2.12 ppm reflect the dishielded effect of the carbonyl group on the adjacent CH3, while the CH2 CH3 coupling follow the n+1 rules. The mass spec data further validates this, as the sum of atomic masses for carbon, 8 hydrogen and 1 oxygen indeed given 72.
Assalamualaikum. My name is Siti Suraimati Zainal. My matric ID is SA23008. Let me walk you through the interpretation of the proton NMR spectrum for our compound. So, starting at 1 ppm, we observe a triplet that integrates for 3 protons. This signal is most likely from a methyl group, or CH3, that's attached to a CH2 group. The triplet patterns happens because the methyl is coupled to the 2 protons on the neighboring CH2 group, which splits the signal into 3. Moving on to 1.6 ppm, there is a hex stack integrating for 2 protons. This corresponds to a middle CH2 group that is coupled with ethyl group. The complex splitting pattern tells us it's interacting with multiple nearby protons. Then at 2.3 ppm, we see a singlet for 1 proton. This is likely from an OH group or hydroxyl proton due to 1 H isolated. Finally, at 3.6 ppm, there is another triplet integrating for 2 protons. This one matches a CH2 group that is bonded to the hydroxyl group. Again, we get the triplet because it's next to a CH2 group. Putting all these signals together, the NMR data strongly supports a primary alcohol structure, and the compound is most likely butan 1-ol or possibly butane 1,4-diol, depending on further structural data or symmetry observed in the full spectrum that will be explained by my teammate.
My name is Muhammad Azib Ahmad Zamani. My matrix ID is SA23009. And now I will explain about the infrared spectroscopy. By refer to the spectrum, there is three substances that show a strong band. For the first one, the most recognizable IR band that have a broad band with the thread of wavelength 3200 until 3600 is referred to the alcohol or OH. The second one is with the stretch of 1050 until 1260 is referred to the ester. And the last one is with the stretch of 2850 and 3000 is referred to the CHSP3.
Okay, my name is Wan Muhammad Afif bin Wan Muhammad. My ID number SA23021. I will be share a carbon-13 NMR analysis of organic compound. Carbon-13 NMR is powerful tool to determine carbon environment in molecule. Now we will explore how chemical shift had identified functional group in molecules. In carbon-13 NMR, sp3 like CH3 or CH2 typically appear in the 0 until 40 ppm range, forming the basis for spectrum interpretation. All carbon are sp3, so the final answer based on the spectrum, based on all the spectrum, which is NMR, IR, MS, and carbon-13 NMR. The answer is CH3, CH2, CH2, CH, which is proton. Let's try calculating the molecular mass to prove it. CH3